So the first thing, when you are multiplying radicals, the big rule is you have to have same index. Okay, you have to. If you do not have the same index, you cannot multiply them together. Okay, so see how this one is a fourth root and this one is a cube root? You cannot multiply those together. The only thing I could do with this problem is to see, could I simplify either one of them? Right? So I look at fourth root of 8, and I know 8 is 2 times 2 times 2. Can I simplify this fourth root of 8 anyhow? No, because fourth root means I have to have 4 of something to take one out. I don't have 4 of anything. I only have 3. So I can't simplify, and this would just stay fourth root of 8. Okay? So let's see if I can simplify cube root of 32. Well, let's break it down. 32 is 8 and 4. And we know 8, again, is 2, 2, and 2. And 4 is 2 and 2. Cube root means I have to have 3 of something to take one out. Do I have 3 of something? 2. I have 3 2's right here. That means those 3 2's, I can take one out. But these 2, that isn't a group of 3, so those have to stay. And remember, whatever stays underneath the radical gets remultiplied together. So 2 times 2 is 4. So what's left would be the cube root of 4. That's the only thing I could do with that problem, is just to look at each term, each part, and simplify. The other thing you have to look out for is if you have the same index, like this next problem, they're both square roots. But what would be wrong when I multiply that? Negative 5 times 5 is negative 25. What's wrong with that? You can't have a negative, right? We no longer recognize complex variables, complex numbers. So since this is a square root, an even index, and a negative, this would be a no solution. So even though they were same index, you still have to be careful that, oh, if it's negative and even index, you can't do it. Okay? And then another example I want to show you is when you have negatives with odd indexes. Yes, you can have negatives with odd. That's okay. But what we need to do is we need to consider this negative to be a negative 1. So it's going to look like this. This would be a negative 1 times 5, and this is going to be a negative 1 times 25. Okay? So what's going to happen is you're not going to try to break down a negative number. Like, you're not going to do 5 and negative 5. You're going to have it be a negative 1 and then break down 25 into 5 and 5. Okay? Because to get a negative number, that negative could go with each number. Okay, so whenever you have a negative, we're going to separate it out before you start reducing down. Okay? So example, if this one, let me change this problem a second. Let's say this is a positive 25, right? Change that to a positive. I think that's what I meant to do in the, okay? So these are both cubic, which are odd, right? So I can combine them together. So this is going to be the cube root of a negative 125. Okay. Now we're going to treat this negative as a negative 1, and then treat that as a 125. So 125 we know should break down into 5, 5, and 5. Okay. Now, if I'm cube rooting, what do I have groups of 3 of? 5 and what else? What's the cube root of a negative 1? You can break down negative 1 into negative, negative, negative. Okay, that's why we separate it out so you don't forget about the negative. Okay, you're not going to put the negative to one of these 5's because then you won't have a group of 3 anymore. So you would take that and make that 3 negative 1's, so then your answer would be negative 5. Okay? So basically, what I'm saying is if you have an odd index and a negative number, your answer is always going to be negative. But don't try to carry that negative down to one of your numbers there, because then you're not going to get your group of 3. Okay. All right, so let's try some with variables, right? Why not? You gotta have variables with algebra 2. Okay, so when you're multiplying and simplifying, you're gonna multiply the numbers in front first, and then you'll multiply what's underneath the radicals, okay? So when I multiply, I'm gonna multiply 4 times 5 first, which is what? 20, good. And then I'll have the square root of 2 times 6, which is 12, x to the second power, because there's 2 x's, and y to the second power. Okay? I combined it all into one term. Now that I multiplied it together and made one term, now I can simplify. And my rule with square roots is I need 2 of something to take 1 out. So let's break it down, see what we have 2 of. 12 is 6 and 2, and 6 is 2 and 3. I have 2 x's, and I have 2 y's. So what do I have groups of 2 of? 2 x's, good. 2 y's, good. And one more? 2 2's, very good. So that means 2 2's, I can take 1 out. 2 x's, I can take 1 out. 2 y's, I can take 1 out. But what's left underneath? This 3 didn't have a partner, so it has to stay, right? So my answer would be this, which would be 40xy, outside here, 40xy. But I would still have the square root of 3, because that 3 was the only thing that I didn't circle. It didn't have a group. Let's try a cube root. Okay, so cube root, again, I'm going to multiply what's in front. 3 times 2, 6. Okay, and then cube root of what? Now here's a trick. You don't have to multiply those numbers together. You can save yourself a step and just leave it 5 times 50, because we're going to have to break that down anyways to find my groups of 3. So it's less work if you just leave it 5 times 50, because then when I break it down, all I have to do is this, 5 and 10 and 5 and 2, right? Because I have to break it down anyways. And then y to the what? Y to the 7th, right? Now, cube root means group of 3. What do I have 3 of so far? 3 5's, very good. How many groups of y's? 2. Yep. And if you can see that, great. If not, if you have to write it out, go ahead and say, oh, there's a group of 3. There's a group of 3. So I'm going to take out 2 y's, and I'm taking out a 5. What's left? The 2 and the y. So my answer then is going to be, let's see, 5 times 6 is 30, so 30y squared, cube root of 2y, what I didn't circle. So here's another cube root one. I'm going to multiply negative 1 times 2 is negative 2. And then cube root, and again, I'm just going to leave it 2 times 15, because I'm going to have to break it up anyways. And then let's see, x to the 2 plus 5 is 7, good. And then y to the 3rd, good. And I need groups of 3. So break down 15, 5, and 3. I have 7 x's and 3 y's. So what are my groups of 3? 2 x's, very good. So I can take 2 x's out. And a y. And here, I didn't have any group of 3 for numbers. So my 2, 5, and 3 all get remultiplied together and become 30. Whatever stays underneath gets remultiplied together. So this would be negative 2x squared y, cube root of 2 times 5 times 3, which is 30, and then this x that wasn't part of a group. Okay. Let's do one more. Let's do this 4th root, and then we can do homework. And think that's probably good. So fourth root, what's my rule with fourth root? I need how many to take one out? 4. You need 4 of something to take one out. So let's see. 3 times 1 is 3. Fourth root, and I'm going to leave that, 18 times 6. And then a to the 10th, because 9 plus 1 is 10. B squared. Okay, so let's find my groups of 4. We need to break down 18. 9 and 2, and 9 is 3 and 3. 6 is 3 and 2. I have 10 A's and 2 B's. So what do I have? Groups of 4. I need groups of 4. Do I have any groups of 4? 2 A's, good. Because here's a group of 4, and here's a group of 4. I could take out 2 A's. Anything else? No. I don't have any. I have 3 3's, but I need 4 3's. So as you can see, when your index gets bigger, you take less out because there's just not that group anymore. So my answer would be the 3a squared. Fourth root. You remultiply all this back together, so it's 18 times 6, which is what? 60 plus 48, which is what? 108? 108? And then what do I have? I have 2 A's left here and 2 B's there. So a squared, B